Hi, my name is Conor, and this is Alex, and that's Hayley over there filming. Hi, Hayley. And right now their first experiment is called the cups in the balloon, and the materials that it requires for it kind of are in the title, but a balloon, and you have two cups right there. Alright, so first of all, what I'm going to do is I'm going to blow this balloon up roughly about a third of the way. Seems, I don't know if that's the third, that seems pretty good.
And then we're going to put both glues on either side, and there's no glue on here at all. I really shouldn't.
Okay, so I'm going to keep blowing it. And we have YOLO. Okay.
As you can see, the cups are sinking to the balloon, and this is because as Conor's blowing air into the balloon, the volume is expanding within the balloon, which causes the curvature of the balloon to expand into the cups. This decreases the volume within the cups, which obviously therefore increases the pressure within the cups, which causes them to stick to the balloon.
Okay. Now see what happens when I let the air out. Oops. The volume of the inside of the cup actually decreases. Increases.
It increases, so the pressure decreases and they no longer use it.
And then they fall off.
Yep.
Okay, so our next experiment is something
We are doing the bionic fingers, which involves two toilet plungers.
Oh, here it is. Blah, blah, blah.
It's over there.
Okay, so this toilet plunger actually has a hole in it.
You can see the hole.
You can see the hole in it.
Yeah. He put a hole in it. And so what we're going to do is we're going to push them together.
Okay.
And we're not going to plug in the hole.
What do you think is going to happen if we pull it out now? Well,
obviously, they can be pulled out, yeah.
Okay. So why does this happen? That's just like that. Just, basic stuff.
There we go. Okay.
Okay.
Yeah. So now we're going to put them together again, but Conor's going to plug up the hole in his.
Plug up this hole.
He's going to plug it up.
And we're going to push it inward.
And we're going to try and pull it apart.
And it's difficult to do so.
Yeah. So if he releases the hole, you can pull them apart. This happens because when there's a hole in the plunger and you stick them together, obviously air is allowed to get in and out from between the plungers, and so it makes it easy to pull them apart. But when he plugs in the hole, the pressure increases because the air cannot get out and air can't get in, so it makes it incredibly hard to pull them apart.
Okay. So what do we have next?
Next we have, we're going to do this experiment.
The balloons?
The balloon and the flask.
Okay, so put this on here, pour the water in.
So what we're going to do is we're boiling about 20 milliliters of water.
20 milliliters. 20
milliliters of water in there to this flask.
And 6 boiling chips. 1, 2, 1, 2, 3, 4, 2 more, 5, 6, and we're going to put that up on this burner.
Onto the burner, which is on about 6 right now.
Okay.
Hopefully it doesn't explode.
Yeah, last time.
Last time it exploded. Okay. So while we wait for this to boil, we can explain sort of what we're going to be doing. So after this has started boiling furiously, we're going to take it off the burner, and what we're going to do is we're going to take a balloon. Conor's going to take the balloon, and he's going to put the mouth of the balloon over the mouth of the flask, and the flask is going to, basically the balloon is going to suck inside out into the flask.
Now this is going to be very hot, so I do have gloves.
So why don't you put on those gloves
Actually,
while we wait for this?
While we're waiting, should we go to the other experiment?
Nope.
Okay.
Yes. Okay. So
It's going to take a minute.
This is the newspaper experiment. Can you hold this, please?
Yeah, I got you.
Okay. So basically, what we have here is a newspaper, the Sentinel, and we've got a ruler. And what we're going to do is we're going to put about 8 inches off.
8 centimeters.
My bad.
Yeah.
8 centimeters off from the edge of the table. And so if I hit this, what do you think is going to happen, Conor?
What? I don't know. What might happen?
It's going to fly up.
It just flies everywhere.
It obviously flies up. Now, though, afterwards.
So this has the centimeters?
Yeah.
Okay.
Okay. Now what happens when I smooth down the newspaper with my left hand and I hit the ruler with my right hand. What do you think is going to happen?
I'm not sure. Let's see and find out.
It's going to break.
It's going to break.
This happens because when you don't smooth it down, there's obviously like a whole bunch of air underneath the newspaper. But when you smooth it down, the air is released from underneath the newspaper, so there's absolutely no air underneath the newspaper. And what's happening is the atomic pressure, the atmospheric pressure from the environment is pushing down on top of the newspaper, which is, the weight of that is about equivalent to the weight of like 2 Subaru cars, which is a lot. So obviously,
That's a lot.
There's the equivalent weight of 2 Subaru cars on top of this, and I hit a ruler, it's obviously going to break.
Okay, so I think our flask is just about ready.
Almost ready there. Yep.
So here, Jenna.
I'll take that.
There you go.
Okay. Why is this taking so long to boil? Let me turn it up a little
Let's
bit.
turn it up just a little bit.
I did. I turned it up to 8.
Okay. So while we are...
Is this our last experiment?
Yes, it is.
Okay. No, it's not. Yes, it is.
Yes, it is.
It is. Okay. Oh my gosh, why is it taking so long? Sorry.
Let's talk about...
Chemistry. Well, you can see that it's almost there. I mean, you can see all of the condensation there on the glass.
Yeah, it's going to start to bubble in just a minute.
It should start soon. Should have put this on sooner.
You know a good joke?
What, Connor?
I don't know. I was wondering if you know a good joke.
I don't know.
Okay. Let's see. Why did the girl fall off the swing?
Is this inappropriate?
No, it's not.
Okay, why did she fall off the swing?
Because she had no arms.
That's so sad.
Yep.
That's not very funny.
It's an anti.
That's an anti-joke. Oh my gosh, why is this not boiling?
I think we're going to continue with that.
Continue with what? Why isn't it boiling?
Boil. Yeah, let's turn it up a little bit. Not like last time.
Wow, it's just really serving a lot of heat over here.
Yeah, it's like on the verge. Like last time we did this, it actually fell apart and broke. And we had
the glass actually fell apart.
That's what I said.
Yes. Well, I was just emphasizing. Oh.
I can actually see it starting to bubble. So
yeah, and the boiling chips are starting to pop.
30 seconds. Thank you for waiting with us.
Sorry, it's been like a minute. You're just staring here at this non-boiling flask.
Yeah, Joey, do your homework or something. I don't know. Chelsea, this is for you. Dolo. That's one of those ones. Hey, it's starting to boil.
Okay, wait for like 10 seconds.
10
20
more
seconds.
seconds. Can you do it? Can you bear with it?
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So
this is
we're gonna take it off.
We will.
You're gonna take it off.
Like that? Yeah, turn that off.
Okay, and he's gonna put the balloon mouth over the quickly.
Count on one balloon over the thing.
Quickly.
Yep.
Stopped boiling. Over the top.
Oop.
Like that. Okay. And like I said before, what's going to happen is you're going to first start to see the air inside of the balloon kind of get like not be there anymore.
Deflate.
It's going to deflate. And the inside of the balloon, right here you're going to see, is going to start to be sucked inward. And this is happening because like when you boil water, the water turns into water vapor, and so the steam is going to form, which pushes the air that was inside of the flask outside of the flask. And so when you keep the balloon attached to the flask, there's like no air can come back inside the flask. And so when you have this water vapor, it creates this sort of vacuum, and it's going. Yeah, you can see it's already been started to deflate. It's going to create a vacuum, which is going to obviously do what vacuums do, and it's going to suck the balloon inside out into the flask.
Now, if you were bored by waiting while it was burning up and starting to boil, watch what happens next. As you might have noticed already, it is already starting to go inward towards the inside of the flask.
Oh,
it's
going.
Oh, just let it happen.
going.
It's almost there. It's so very close.
It's going. Bam! Look at that. Look how cool that is. That just does not happen on a daily basis.
If anybody feels they're disturbed by the footage, they are allowed to leave.
This is just insane. So yeah, that is our experiment.
That is what you need to know about pressure exertion.
Yep.
Yep. All right. Thank you.
All right. Thank you. Have a good day.
I love you.